Hello, chemical systems. So in this video, I'm going to introduce you to and work through some problems of balancing chemical equations. So remember that chemical equations show us what happens in a reaction. For example, the equation I have on screen is the formation of hydrogen peroxide. Hydrogen gas plus oxygen gas reacted in the right way can give you hydrogen peroxide. H2O2 is this chemical formula. And so the so like I said, we use these equations to help us understand what's going on, how reactions take place. Um, what I mean by balancing equations is that when we combine elements together, we know what the reactions are, we know what the products are, but we don't necessarily know what proportions they are that go together. And knowing the proportions are pretty important for manufacturing chemicals or just understanding the reaction. For example, if I want to combine hydrogen and oxygen to get hydrogen peroxide, I need to know how many grams of hydrogen, how many grams of oxygen do I combine to without having anything left over. So that's why this is important. That's why we do it. So let's just go through some steps on how to balance a reaction. So the first thing we need to do is we need to count how many of each element or how many of each atom we have on each side of the equation. So I'm going to make a table. I'm going to be using this table a lot. I recommend that you make a table as well when you balance equations. I'm just get my tools ready here. So I'm going to make a table for reactants and a table for products, or sorry, a column for reactants, a column for products. And so in this equation, I just have two atoms on each side. I have hydrogen gas and I have oxygen. I shouldn't say gas. I have hydrogen and oxygen. They're in different states on either side, but we're not going to worry about the states matter. And so I'm just kind of going to make a count of how many I have on each side. So on the left side, I have two. Well, actually, before I even see how much I have, I just want you guys to remember that these chews here, that tell us how many atoms are in that molecule or in that element. So, for example, here I have H2 means is the same thing as saying 2H, except H2 I know that they're chemically bonded. But either way, I have two hydrogen atoms and two oxygen atoms in the reactants. And then if I looked on the product side, I have two right there, two right there. So that means I have two hydrogen and two oxygen. So this equation does not need to be balanced because everything's even. Everything's already accounted for. So when you have an equation like this is already balanced, there is no need to modify anything. In the next example, I'll show you writing coefficients, but for this, in this case, I'm just going to say I have one. If I have one of each, that's all I need. So one molecule of hydrogen gas plus one molecule of oxygen gas will give me one molecule of hydrogen peroxide. There's no need to change these, what are called coefficients. In the next example, we will see how those coefficients can be changed. So I'm going to click on next here. And by the way, I'm using Edge Elastic for today's work. But if you can't get Edge Elastic to work, please let me know. It should work whether you're using a mobile device or a computer. But it's my first time using it. It's just going to make this assignment a whole lot easier for everybody. So, but if you have problems with it, please let me know. Okay, so let's look at this next one here. So we have the formation of water, which is actually very similar to hydrogen peroxide, but it's just one less oxygen atom. So hydrogen gas plus oxygen gas yields water. Okay, so let's start our table. So on the left side, H2, that means I have a hydrogen molecule with two atoms. O2, well, that's two oxygens. Product side, the right side, I still have that H2, so I still have two hydrogens. but I only have 1 oxygen. Okay, now there's a problem because now even though my hydrogens are automatically balanced, my oxygen is not. So how do I fix this? If you watch the video today, they don't really give you any tips on how to fix this. A lot of this is just trial and error. So one inclination might be, oh, I can just take this O2 and change that 2 to a 1 and have O1. Well, the thing is that we can't do that because those subscripts, these are called subscripts, we cannot change those subscripts because in real life, we cannot just decide, okay, I'm going to break up these diatomic atoms and do willy-nilly with them. So I can't change the subscripts, but what I can change is the coefficients. What's going to go in these blanks, like you saw in the previous slide, those are called the coefficients. When I'm balancing an equation, I can change the coefficients. So how do I know? So I have to do something with this coefficient right here, but how do I know what number to put in there in order to make something equal? I guess I say it's gonna. Well, I know that at least those two have to change because my oxygens are unbalanced. So how do I know what to put in those blanks? Well, one easy way is just to look at my oxygen row, which is the row that's unbalanced, and then just multiply them by each other. So what I'm trying to say is that I multiply the reactant side by the number that's on the oxygen side. So 2 times 1. That's a horrible one. And then multiply the products by what's on the oxygen side, or sorry, multiply the products by what's on the reactant side. So on the reactants is 2. So if you want to call it cross multiplying or whatever. So the number I get over here is 2. And the number I get over here is 2. So so what this does not tell me, this does not tell me what to put in the blanks. This does tell me how many of each I should have on each side of the equation. So this tells me that on my reactant side, I should have 2. Well, I already have 2. So there's no need to modify this coefficient. I could just type in 1 because I want to keep that 2. On the right side, I should also have 2. So what do I need to make this? If I want 2 oxygens over here, what coefficient do I need to have here in order to have 2 oxygens? Well, I need to put a 2 because there's an understood 1 right here. So don't forget, when you're working with these subscripts, when there are no subscripts, there's an understood 1 at the end of that oxygen. Anyway, so I need to have 2 over here because I need to have 2 oxygens. Now, that multiplication thing might seem a little obvious, like, well, duh, I need 2 oxygens. Why can't I just type in 2 there? I'm kind of doing this as a process to get you used to because it might get a little more complicated in the next few problems. Anyway, so now let's just kind of recheck everything. So and actually, I'm just going to go ahead and erase this stuff here. So just kind of rechecking everything. Now I have 2 hydrogens on the left side, and I have, well, now over here, in order to find out how many hydrogens I have, because I have this coefficient and the subscript, I have to multiply the subscript times the coefficient because I have 2H2, which means I have 2 hydrogen molecules with 2 atoms each. So I have to multiply those 2. I have 4 hydrogens on the right side. I have 2 oxygen left and 2 oxygens on the right. So now I can see that, well, because I had to modify that oxygen, now my hydrogens are unbalanced. But this is an easy fix because if I look on the left side, well, I have an H2 right here. Well, what do I need to multiply that H by in order to get, or what do I multiply that to get 4 hydrogens? Well, I already have 2, so I just need to multiply it by another 2. Okay, so again, I'm just going to go ahead and do a final count to make sure everything is balanced because I've modified everything. So everything should be balanced now. So I should have, so on the left side on the reactants, 2, oops. So 2H2, so 2 times 2, that's 4. 2H2O, so 2 times 2 again is 4. I have 4 hydrogens on each side. 1 O2, so 1 times 2 is 2. 2H2O, I have 1 O, so 2 times 1 is 2. So yes, everything's balanced. Now I kind of took my time doing that because I'm trying to get you guys used to a process. And if you guys watch the video that I gave you today on today's agenda, he might go with it a little more smoothly than I just did. But if I was going to just kind of go through this without making if that table is confusing you, let me just kind of, if I were to just to start over, just to read what I said. So again, the problem is here, if I just leave the equation like this, I have 2 oxygens on the left side. I only have 1 on the right. So I need to make the right side even. And this throws off my hydrogen count. So now I need to make the hydrogen count even on the left side. And to do that, I could just say add a 2 over there. So now I have 4 hydrogens on the left side, 4 hydrogens on the right, 2 oxygens on the left, and 2 oxygens on the right. Normally, when you write these balanced chemical equations, I don't need to write anything at all here for this coefficient. But because this is kind of coming at you at a quiz format, I'm just going to just go ahead and type in that 1 in order to get the question right. Okay, so before I beat a dead horse, let me just move on to the next question. Again, I'm going to make a table. So I'll just make a table for the reactant side and the product side. And so I'm dealing with more than 2 chemicals. Now I have 3 chemicals to worry about. So this is the decomposition of calcium chlorate, perchlorate. I can't remember all my chemical names. Might come as a surprise to you. There are lots of chemicals out there, guys. Okay, so I have potassium, K, chlorine, Cl, and oxygen. And it's important to remember here. Let's just look at this real quick. This is review. Let's look at calcium. I think this perchlorate. Pretty sure. So remember, it's just don't forget how to read these. So when you have all of these symbols here next to each other, don't forget how to separate these into their different atoms. Remember, every element name starts with a capital letter. Some elements have more than 1 letter, but it will always start with a capital letter. So Cl is an element, even though it has 2 letters. So Cl is its own element, potassium is its own element, and oxygen is its own element. Okay, so remember, capital letter is the beginning of a new element. Okay, but so that's just a little bit of review. Just don't forget how to do that. Okay, so let's go back to the table here. So I'm trying to count how many of each atom I have on each side. So on the left side of this equation, I have 1 potassium. Right side, I have 1 potassium. Well, that's good. Left side, I have 1 chloride. Right side, I have 1 chloride. I know I have 1 because on the left side, there's no coefficient and there's no subscript under potassium or chloride. Oxygen, left side, I have 3. Right side, I have 2. Okay, so my oxygens are unbalanced. And it's not as simple as last time where there's 1 and 2 or something like that. So how are we going to fix this? So I know I need to balance my oxygens. And the easiest way to do that is to just multiply both sides by what's on the other side. So multiply my reactants by 2, because that's what's on the other side. Multiply my products by 3. And I should get the same number on both sides. This is just a cross multiplication. So in both cases, this gives me 6. So I know I should have, when I'm finished balancing my equation, I should have 6 on both sides. So I multiplied the right side equation by 3. So I put a 3 here. And on the left side, I put a chew. Now, it's important to note that I can't just squeeze in coefficients between atoms. What I mean by that is that I can't just say, okay, for potassium perchlorate here, I can't have KCl2O3. I can't just insert stuff, because remember, this whole thing is one molecule. If I was going to try to squeeze two extra, or I guess three extra oxygens in there, I would be making a whole new molecule, and that just wouldn't make sense. So I know that you're looking at it. I was like, oh man, that unbalances my potassium and chloride now, because now I have more potassium and chloride. Well, it's an easy fix, because look, now I have 2 KCl. Over here, I have KCl by itself. So if I have 2 KCl on one side and I have KCl by itself over here, I could just type in a 2 to make it even. So, and if you're not sure what to do next, you could just remake the table. And I'm going to remake the table right now just to check my work. Okay. So reactants, on the left side, I have 2 potassiums. On the right side, let me get my blue back. On the right side, I have 2 potassiums. Left side, 2 chlorides. Right side, 2 chlorides. Left side, 2 times O3, that's 6 oxygens. Right side, 3 times O2, well, that's 6 oxygens. So everything checks out. This is all balanced. Hope that makes sense. We're going to do one more problem together. This one is a little bit tricky. It deals with what's called polyatomic ions. I don't want that name to scare you. Well, let me show you what I mean. And let me get rid of these marks here. This is not the one I was thinking of. Let me pause the video and make sure I'm finding the right problem here. Oh, you know, I think it's the next one. Never mind. Polyatomic comes next. I still wanted to do this one with you guys, but there's something else coming up in a little bit. Okay, so let's look at this one together. Okay, so here I have carbon, I have sulfur, I have oxygen. Yep, that's it. Okay, so let's balance this equation. Let me check my notes real quick to make sure I'm not missing any explanations here. Yeah, okay, cool. Okay, so let's balance this out. So on the reactant side, on the left side of the equation, I have 1 carbon. On the right side, CS2, that's carbon disulfide. I have, again, 1 carbon. Left side, SO2, well, the S has no subscript, so I have 1 sulfur. On the right side, S2, okay, I have 2 sulfur, so I know automatically that's unbalanced. Left side, oxygen, O2, I have 2 oxygens. Right side, oops, oh, I messed something up actually, guys, I'm sorry. You guys see where I messed up? I'll come back to it, but look at the carbon on the first row there. Right side, product side, I have 1 oxygen. And where I messed up was when I did carbon on the right side, I said I have 1. Well, I only looked at 1 molecule. There's a CS2 and there's carbon monoxide, which is CO. So actually, I have to count for both of those. So that would be 2 carbons. Okay. So there's actually a lot of things I had to balance here. Again, so there's a lot of things that's not balanced. And if you're not sure where to start, we'll just take a guess. Because even me just looking at this, like, I'm not sure where I would start. One clue, it might be intuitive just to say, hey, I'll start with that first and it's by itself. If something's by itself, don't start with that one first. because if something's by itself, it's easier to modify that last. What I think I'm going to do first is the carbon monoxide. I know I have 2 oxygens on the left side and 1 on the right side, so I'm just going ahead and multiply again, multiply them by each other. If it'll let me draw. There we go, 2 times 1 and 1 times 2. So I don't have to change anything on the left side, but on the right side, I'm gonna multiply that oxygen by 2. Okay, so that takes care of the oxygens. Now let's take care of the sulfur. So sulfur on the left side, I have 1. Sulfur on the right side, I have 2. So again, multiply that by each other. Oops. So times 2 times 1. And you guys might see that some of you might see I'm about to run into a problem. So a lot of it, like I said, a lot of this is trial and error. So now I balance my sulfurs, but at the same time, I upset my oxygens. So it might not have been the best idea to start with oxygens after all. Again, just some trial and error. But I'm not gonna undo what I did with sulfur. I'm just gonna keep on going and retry that carbon monoxide, the CO on the right side. So as the equation stands right now, 2 times O2, right now I have, oh, whoops. That was weird. Right now I have 4 oxygens. And then on the right side, I only have 1 oxygen. I got that 4 because 2 times that subscript 2, I know I have 4 oxygen atoms. Okay, so if I multiply these times each other, well, okay, now I see I need to multiply that by 4 in order to even out the oxygens. My sulfurs are still balanced. And now my oxygens are balanced. I have 4 on each side. But now the only thing left to balance is the carbon. So I can go and put this 1 right here. So I have, let me update my carbons here. I should have done that a while ago. So now I have 5 carbons on the product side, because 4 times that 1 times that 1. So 1 plus 4 is 5. I only have 1 on the left side. So this is really easy. I just multiply, cross multiply. So nothing needs to change on the right side, but on the left side, I should multiply that carbon by 1. So see, since it's by itself, it's much just easier to say that for last. So there we go. I don't think this one was a little bit difficult. I don't think you should find one quite this hard on the problems that I picked for you to do. So I'm doing the first 5 with you guys, but and you guys will do the last 4 by yourself. So it's kind of a perk of watching the video. Okay, last problem that we're gonna do together. So, I have to make some more room. So I was talking about polyatomic ions. And right now I know this looks like a lot because there's lots more letters, but don't let that throw you off. Just kind of breathe, break it down. Don't forget simple things like CO, that's 1 type of atom. Br, that's 1 type of atom. So it looks like 4 atoms, but there's only 2 atoms there, or 2 types of atom. It's cobalt tribromide, cobalt and bromide. Same thing here, well, not the same thing here actually. So this is where I'm going to talk about polyatomic ions. So you see on the right side how we have an SO4, SO4 in parentheses, and there's a 3. That tells me that there are 3. If I was going to multiply that out, it would look like S3O12. And the reason they don't multiply that out, you could, it would still be technically correct. The reason they don't multiply that out to its full extent is because SO4s, that tells me that the SO4s are a unit of that molecule that don't separate. It's called polyatomic ion. Ion, remember, is a molecule that has charge. So when you see things that don't change from one side to the other, or we see an entire unit of atoms that are grouped together or they don't change, that's how you should account for it when you make your table. Let me show you what I mean. So I'm going to make and this is going to be the final problem we're going to do together. I'm going to make my reactants product table. Reactants, products. Okay. So on the left side, I have cobalt, bromide, calcium. And instead of saying sulfur and oxygen, I'm just going to say SO4. So I'm going to count the number of SO4s that I have, because that's kind of like a unit. So I'm not going to try to separate it and count that and balance that separately, because it's just going to get way too crazy. So I'm just going to, if you see something that has a unit like that, and usually it's like ClO3, or there's usually an oxygen in there, not all the time, but most of the time there is. A PO3, PO4 is another example. But if you see them grouped together, especially like they did on the right side here, just pretend like it's its own atom or its own element. It really helps. So let's just do a count. Cobalt on the left side, there's no subscript, so I have 1. Cobalt on the right side, I do have a subscript of 2, so I have 2 on the product side. Bromide on the left side, or sorry, bromine, I have subscripts of 3, so I have 3 on the left side. Product side, I have Br2, so I have 2 on the product side. I can already tell there's going to be quite a bit of balancing in this one. Left side, calcium, I have just 1. Right side, I have just 1. So maybe that's a ray of hope there. SO4, I have 1 on the left side and 3 on the right side. Okay. So again, where do I start? Well, it's just going to be a little bit trial and error. Definitely don't start with calciums, because those are already balanced. I could probably come back to that's probably one of the last things I'll come back to. Let's just look at one of the things that is unbalanced. So I got cobalt, bromide, and SO4. So I think because anything that has a 1-to-2 or 1-to-3 ratio, or anywhere there's 1, I think is probably a safe place to start. So I'm just going to start there. I'm going to start with my cobalts. So cobalts, looks like I need to multiply the reactants by 2. Don't need to multiply the products by anything. So if I put 2 here, so now my cobalts are balanced on the left and right side, but my bromide is now different on the left side because I multiplied that by 2. So now I have 6 bromides instead of 1. Okay, so now I'm going to try to fix that. This is one of those cases where it may be better not to multiply them by each other, because if I want to get my bromide on the right side to equal the left side, well, I already have 2. I want to balance it to get to 6. Well, I just need to multiply by 3. So I'm just going to multiply that by 3. Okay. So now, let's just kind of let's kind of go back, breathe, and see what we need here. So that threw off my calcium. So I'm going to, oops, only threw off my calcium on the left side. So still 1 on the left side. Right, I'm sorry, right? Oh man, can't talk. And since my calcium is attached to that sulfur, or sorry, SO4, I'm going to do the SO4 right now before I mess with the calcium. Like I said, the calcium is going to be the last thing I do. I will go and adjust it on my table because I think it might be worth mentioning. Again, how am I coming across this? Some of this is just to intuition, but some of it is just going to be trial and error. And this is the hardest one. You're going to have one like this. So anyway, 3 calcium. So I have 3 calciums. That's what I'm going to do. Okay. Before I touch calcium, I'm going to try to see if I can balance that SO4. So I have 3 SO4s on the right side, and the left side has, oops, that looks like a 2. Sorry. Just do that 1. So I'm going to cross multiply. 1 times 3 times 3 times 1. So I don't need to change the right side. I already have 3. Left side, I need 3 SO4s. So I'm just going to type in 3 right here. Okay. So that touched my calcium on the left side. And actually, it looks like I don't need to do anything at all because it automatically fixed itself. And sometimes when you do these, you find that, oh, that fixed itself. It happens sometimes. And so I didn't have to modify anything on the last group here, the CO2SO4 So I'll just leave a 1 there. And if you think you got it, if your table looks like it came out even, go ahead and just do a final check. That's what I would do. That's the only way to know if you truly balance the equation is if you count the atoms again to make sure it's completely balanced. So on the left side, I have 2 times the subscript of 1 for the cobalt, so that's 2. 2 times 3 on the subscript of bromide, so that's 6. 3 times no subscript, so that's the 3 for calcium. 3, well, again, 3 times SO4, that's still 3. On the right side, I have 3 times the subscript of 1 for calcium, so I have 3 calcium. 3 times the subscript of 2 for bromide, so I have 6 bromide. 1 times CO2, so I have 2 cobalts. And 1 times the subscript of 3, I have 3 SO2. So yeah, 2, 2, 6, 6, 3, 3, 3, 3. Everything's balanced. Remember, the important thing here is that when you see like something grouped like this, it's grouped for a reason. So treat it as if it's its own element, even though it's really not. Those are called polyatomic ions. So I did the first 5 problems with you guys. I really hope that helped you kind of get the full process down. Make a table, count how many on each side, and then cross multiply, and then whatever numbers you cross multiply by, put those in the coefficient boxes. One last hint that I'll give you guys that I just thought of. I'm going to go back to, first let me clear off my drawing here. And guys, if you need to, take advantage, I put these on YouTube. So if you need to pause and rewind, please do that. So let's say that I was balancing this equation, the formation of water. Let's say I came out with something like, I was balancing this and somehow I got these numbers here. 6H2 plus 3O2 yields 6H2O. This is balanced. 6 times 2 is 12 hydrogen. 6 times 2 is 12 hydrogen. So I have 12 hydrogen on each side. 3 times 2 is 6 oxygen. 6 times 1 is 6. So I have 6 oxygens. This is balanced. But you notice that all of these numbers are multiples of 3. In other words, if I had a fraction that looked like this, if I had 6 divided by 3, I know I could reduce this to 2 divided by 1 because these are both divisible by 3. So if you find yourself balancing an equation and you have numbers that have the same common factor, well, then you should reduce it. If you don't reduce it, well, then it's counted wrong, because the whole point of balancing these equations is to find the lowest coefficient possible to put in these blanks. So you would want, if you, the reason I say that is because sometimes cross multiplication might lead you down this path. So dividing each number by 3, I would get back to my original coefficients. And so please, 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 if you find yourself in that situation, just look at these numbers and ask yourself if you can reduce them or not. I think that I'm going to check my notes. I think that's all I had to share with you guys on this video. So, yep, that's all. So today we're going to use this as classwork for today. On Tuesday, when we come back from our holiday, we are going to do a quiz over this. So you guys might have some similar problems. I might just have some problems where I'm going to ask you, is this balanced or unbalanced? You don't have to actually balance the equation, but you have to tell me if it's balanced or unbalanced. But today we're just going to work strictly on balancing these equations. I gave you guys this lecture video. I gave you guys a reading from CK12 and also another YouTube video from a chemistry teacher. Please use those resources to your advantage from the agenda. If you have any questions, please let me know. We'll have Zoom hours on Thursday and Friday. I'll talk to you guys later. Thank you for watching. Bye.